Hi everyone. So this is just a quick video on lab number 4, Intro to Mole Concept, on how to get started. So this lab is very important because it has to do with you understanding the mole concept. And this mole concept will continue to kind of play this domino effect in terms of it's going to keep coming up in future assignments. For example, in the following chapters about stoichiometry, understanding how to calculate moles and what moles are is very important. So that's what I mean by domino effect. So, like I said, it's just to get you started. I'm not going to go through every single step for the entire lab because, the whole point is you are to explore and learn in that sense, through, a little bit of trial and error here and there, and just exploring through the lab and learning. So this first section has to do with understanding what a mole is, how much is a mole, and how a mole, the mass, for example, of a mole can change depending on what your substance is. By substance, we mean elements, we can mean compounds, we can mean many different things. In this particular case, we are talking about elements. We're working with pure elements. So here I'm being instructed to work with element 3. And I highly suggest you open up this hint section because it lines out what you need to do. So select element 3. So that's my first task. Now, it gives you the overall instructions. Make a graph showing the number of moles of element 3 on the horizontal axis and the mass on the vertical. However, that doesn't break it down, but luckily this hint part does. So click change on the bottom of the video. We already did that, actually. That's pretty easy. Press load. We did that. It is showing 1 mole right now currently or it's going to show 1 mole for element 3. Enter the mass in the data for the mass. Okay, I just repeated myself too much. Enter the mass in the data table for the mass that you see. That's what it's trying to say. Click change again, and then you keep doing the same thing for all the way to 5. So we are going to hit play. And first they put the weighing boat. Obviously the weighing boat has matter, right? So it's going to show a mass. It weighs something, right? And we don't want that to interfere with our mass, so they tear it. In other words, they zero it out. That's what that happened just now. Okay, now they're weighing the substance that we don't know what element it is, but it's an element, and we see that 1 mole, right? This corresponds to 1 mole. So I'm going to record that data right here. That weighed 207.2. And like the instructions say, you are going to click change again, do the same thing for 2, do the same thing for 3, and keep going. Now here I skipped ahead to 3 and see how they're changing out what they're using to weigh, because it ends up being a lot from you're about to see right now. See, that's a lot. So just make sure you're recording on the right one. So for 3 moles, I would have to record right here on the 3rd row for 3 moles corresponding to that. So for example, I would write, obviously you wouldn't skip how I did, but just for these purposes, oops. Make sure you're typing, not like me. 1.6. Okay. And luckily it's already showing a pattern just for these purposes of me demonstrating it. So don't forget, because I'm grading this right, so manually, don't forget to tell me what element you got right here. All you have to do is double click it and it allows you to edit. Now, luckily for us, again, go ahead and edit. I don't know why it was showing twice, but yeah, ignore that other column. But you can change the name so it's more reflective of what we are working with. So here you might have noticed that this line was not there. But now that we entered some data, it's showing that. So the way that this is working is that the moles column is coming from this set of data, and then the masses are coming from this. And let's double check that this matches what we were instructed to do. So the number of moles of the element should be on the horizontal axis, in other words, the x-axis, and then the mass of our element should be on the y-axis. So this is exactly what you should do. You should fill out all these measurements, and then if it's not already there on the x-axis, you should click it and make sure that it's populating moles. And then on the y-axis, you should make sure it's populating and taking that mass data. This we can remove that. It just needs to be one. And then it'll give you this trend line. Now, from here, you're going to answer some questions. Students must answer this question, right? In order to get to everything else. So use the linear fit tool to find the slope of the graph. So this right here is very important. What this is information related to this line. This line is going to tell us a lot of information. I know it doesn't look like it, and I know you're probably just like, slopes, what does that mean? I forgot everything from math. It's gonna tell you some information related to what we're working with here. Okay, so here, this is giving you a line. Y equals mx plus b. M happens to be called A. N is your variable. B is still called B. That's just your intercept. So you don't need to overthink that. All you need to do is extract some information from there. So your A is your slope. And here this is telling me that my slope is 207 g over mole. So here I would put in that my answer is 207, right? So that information's right there. Nothing much to, overthink. Next, identify the units. Luckily, that's also being given to you. So grams per mole. But let's talk about this. Let's think this through. So we know that slope is calculated by taking the change in y divided by the change in x. And if we look at these units, it's basically g, right, which is our y, divided by, in other words, over, rise over run, remember, from algebra, g over mole. So this does match, right? We're trying to confirm this. This does match what our slope is telling us. So I would answer that, right? And of course, it reiterates everything we just talked about. Oh, and it gave you that hint as well. So the units for the slope are gram per mole. Now, another way to reword this is to think about, and also for us to go back to our original data set. So if you take all these 5 measurements, you're going to notice there's a pattern. That when you take the measurement for 2 moles, it's times 2, this original number for 1 mole. And then if you notice, 621.6 is actually a multiple of this times 3, right? So 207.2 times 3 gives you 621.6. And that's not an accident. It's because 1 mole is this, and then now we're weighing 2 moles and so on. And the point of me talking about that is that there's a pattern, right? So for every 1 mole, you're going to increase 207 grams, right? Our moles are increasing by a unit of 1, and then our grams are increasing depending on the element. This number all depends on the element that you're working with. So I'm going to leave it there just so that you can get started. Now I'm remembering why it had 2 columns. So your table will have 2 columns, and the whole reason for that is because you'll be doing the exact same thing we just did for element 6, or whichever one it happens to give you, because I think it varies sometimes. But that's how you're working with this data, and that's how you're recording and generating your graph. Section 2 also has you, working with some videos and recording some data, but don't be afraid of it. Just know, don't be afraid of the math, especially, and of the graph part. I know it looks like it's a lot of algebra and a lot of math, but in reality, we're just taking some information out. So once again, I'm here for you. If you have any questions, just let me know. And you have enough time, you have ample time for this lab. So take your time, one question at a time, and I'm here if you have any questions.